Hello students, in this video we'll see an example of solving a second-order linear differential equation with non-constant coefficients using reduction of order. Let's consider the ODE, tangent squared x times y double prime minus 2 tangent of x times y prime plus 2 plus tangent squared x y equals 0. There is a second-order linear homogeneous differential equation, and the coefficients are not constant, something we're not really used to seeing that often. But the beautiful thing about this is we can use reduction of order. We know that if we can find one solution, we can reduce the second-order equation to a first-order equation. And so with any trigonometric function like this, with trigonometric functions, I always see if I can find a simple solution first before I look for more complex solutions. So let's show first that y equals sine. I'm going to call this y1 is equal to sine of x, solves the equation. Okay, so let's check. So if I have tangent squared of x, the second derivative of sine is negative sine, so it's going to be a negative sine of x. And then minus 2 tangent of x times cosine of x, because the first derivative of sine is cosine. And then I have a plus 2 plus tangent of x squared, and then times the original function, which is just sine of x. So of course we see that that negative tangent squared of x sine will cancel with this positive tangent squared of x sine. And then this tangent times cosine is of course equal to what? That's of course equal to sine of x. So that's a negative 2 sine x, that's a positive 2 sine x, that will cancel. So indeed, sine is a solution to this problem. Now we're going to use reduction of order. What does reduction of order tell us to do? So reduction of order tells us to look for solutions y that have the form v times the solution you know, v times sine of x. And I'm going to write this, of course, just as v times y1, where we know that y1 is the solution of the equation, right? So in other words, if I plug in y1 up here, we know that we'll get 0, and that's an important observation in this. So let's start doing derivatives. So if this is the case, then y prime is going to be v y1 prime plus v prime y1. And v double prime, by the double product rule, is going to be v y1 double prime plus 2 v prime y1 prime, and then plus what? I have to do a v term, so now I have a v double prime y1. Okay? And now we have to fill this into the equation over here. So let's do that. So we have tangent squared times y double prime. So our new equation becomes tangent squared of x times y double prime, which is v double prime y1 plus 2 v prime y1 prime plus v y1 double prime, and then minus 2 tangent of x times y prime, which is going to be a v1 y1 plus v y1 prime, and then finally plus 2 plus tangent squared of x times what? Times just v y1. Okay, and we want this to be equal to 0. And so now what do we know when we do reduction of order? When we do reduction of order, all the terms that involve just y1 are going to the y1 prime terms are going to cancel. So if I look at this term over here, that is a y1 double prime times tangent squared times a v. If I look at this term over here, that's a v times y1 prime times negative 2 tangent x. That's great, that's a common factor of v. And then finally, this whole thing is just going to be a v times y1 prime. So all three of those highlighted terms over here are going to cancel out. So that cancels, and that cancels. And that always will happen with reduction of order. And that leaves us with a more elementary equation. So what is this more elementary equation? This more elementary equation now, and I'm going to write what these y1s are. So this is going to be tangent squared x times v double prime. Remember that y1 was equal to sine, so that's going to be a sine of x, plus 2 v prime, then y1 prime, derivative of sine is cosine, so that becomes a cosine of x. And then I have minus 2 tangent of x times v prime, and then times a sine of x is equal to 0. Now, what's the observation over here? Let's look at these, let's make an observation the observation is that if I look at tangent times sine, so tangent times sine is sine squared of x over cosine of x. That's what this term looks like over here in terms of trig functions. And then let's look at this term over here, tangent squared times cosine squared. Tangent squared of x times cosine of x is going to be what? Well, the tangent squared is sine squared over cosine squared, so one of the cosines is going to cancel out. So that's sine squared of x over cosine of x. So in fact, this term over here and this term over here are going to cancel out as well. And so all we're left with is this equation, that v double prime times sine x times tangent squared x is equal to 0. And of course, that tells me that v double prime has to be 0. And that's beautiful. That's easy to solve. That's v is going to be c1 plus c2x. And now we found a general solution of our second order equation. The general solution of our second order equation is v times sine. So my y is equal to sine of x times c1 plus c2x. So my general solution is c1 sine of x plus c2x sine x. And there's our general solution by reduction of order. Thank you very much.